Assalamu alaikum. Today, inshallah, we'll be solving March 26, paper 1, variant 2, question number 1. Which statement about p orbital is correct? All p orbital have this shape, dumbbell shape. This is correct. All p orbitals have lower energy than s orbital. This is wrong because S is always less than P in energy. The first 4 quantum shells contain p orbital. No, the first one contain only S. Each p orbital contain maximum of 6 electrons. Wrong. Each p subshell, no p orbital. P subshell has 6 electrons, or each p orbital has 2 electrons. So the answer is A. Question number 2. The first 4 ionization energies of phosphorus, atomic number 15, are shown. 1, 2, 3, 4. Around the fifth, because phosphorus contains 5 electrons in the outer shell, this is the electron configuration of phosphorus. The outer shell contains 5 electrons. So there will be a great difference or a big change between the fifth and sixth energy, ionization energy. And also in the inner shell, when you remove the inner electrons, these 8 electrons, so the ionization energy needed to remove the electron from this shell will be higher. So there will be a great difference between the fifth and sixth ionization energies. And in the same time, when you remove all of these 8 electrons, so there will be a great difference between the 13th and 14th ionization energy, because when you remove this 5 electrons and this 8 electrons, so you remove 13 electrons. So when you move to an inner shell, which is the first shell, so the 14th electron will have a very high ionization energy. So you have to choose here the sequence that has a great difference between the fifth and sixth. So in this case, B and C are correct because there is a big change between fifth and sixth ionization energy. Also, you have to choose the one that contain a very great difference between the 13th and 14th, because 13 is the end of the second shell, and 14th is the ionization energy needed to remove the electron from the first shell. So the answer is B. 3 sodium carbonate neutralizes phosphoric acid to form carbon dioxide, water vapor, and sodium carbonate. This is the equation. Okay, sodium carbonate plus phosphoric acid gives sodium phosphate plus water plus carbon dioxide. Which volume of 50 centimeter, 0.5 mole per decimeter cube sodium carbonate needed to exactly neutralize 40 centimeter cube of 0.25 mole per decimeter cube phosphoric acid? Okay, right. So we have the volume and the number of moles of the volume and concentration of phosphoric acid. We can get the number of moles from here. We can get the number of moles. We have here 0.25 times 40 over 1000 equals 0.01. So this is the number of moles of phosphoric acid. And since the mole ratio between phosphoric acid, as you can see here, the mole ratio between sodium carbonate and phosphoric acid is 3 to 2. And the number of moles of phosphoric acid is 0.01. So the number of moles of sodium carbonate is 0.01 times 3 divided by 2 equals 0.015. Since we have here the number of mole of sodium carbonate and the concentration of sodium carbonate, so we can divide this number of mole divided by the concentration times 1000 to change the volume from decimeter cube to centimeter cube, because all the answers here are given in centimeter cube. So the answer will be 30. Okay, 30 centimeter cube. Which equation describes the complete combustion of alkene CnH2n? CnH2n, I'll give an example first. CnH2n plus O2 gives CO2 plus H2. Imagine that we have, for example, propene. Propene C3H6 plus O2 gives CO2 plus H2O. Since we have 3 carbon here, so we have to multiply this by 3. And since we have 6 hydrogen here, we have to multiply this hydrogen by 3. Okay, so if this one is N, so this one should be N and this one should be N. But let's count the number of oxygen. The number of oxygen here, 3 times 2 equals 6 oxygen. And here 3 times 1 equals 3 oxygen. So total 9 oxygen. So 9 oxygen. So here we will multiply this by 4.5. 4.5. And since N here equals 3, okay, so we have 1.5 N. So the equation will be CnH2n plus 1.5 N equal N CO2 plus NH2O. Or you can find it in different ways. CnH2n plus O2 gives NCO2 plus NH2O because here Cn, so the number of C here should be N as well. Okay, the number of N here should be, if this one is N, so here it should be N and here should be N because H2N and here H2 we have to multiply it by N. So N beside CO2 and N beside H2O. But regarding oxygen, we have from carbon dioxide multiplied by N, so we have 2N oxygen, and from water we have 1N oxygen. So total we have 3N oxygen. To make this oxygen like this oxygen, we have to multiply it by 3 over 2. Oh, okay, 3N divided by 2. So here 3N divided by 2 oxygen or 1.5 oxygen. So finally, we will have the same general formula. So CnH2n plus 1.5N equal NCO2 plus NH2O. Question number 5. Organic nitrates in photochemical smoke can cause breathing difficulties. The diagram shows an example of organic nitrate molecule. This is the organic nitrate molecule. What is the correct order for the bond angle shown in ascending order from the smallest to the highest? On here, this carbon, it has 4 bonds, 1, 2, 3, 4. These 4 bonds make the hybridization here sp3, and the bond angle is 109.5. And this carbon, it makes 3 sigma bonds. So the hybridization is sp2 and the bond angle is 120. And this O, it makes 2 sigma bond and 2 lone pair. So the bond, it looks like water. So the bond angle is 104.5 because we have 2 bonding pairs, as here, 2 bonding pairs and 2 lone pairs. So the smallest angle will be 3, then 1, which is this one, then 2. So the answer is C. 6. Which dot and cross diagram is correct for Al2O6? Al2O6 is covalent molecule. So the first answer is wrong because this is for ionic compound, and we know that for AlCl3 we have 2 coordinate bonds. The Cl here, as you can see here, between Al and Cl there is covalent bond by sharing 2 electrons, 1 from Cl and 1 from Al, and also this Cl3 the same. But here and here, between this Cl and Al, there is coordinate bond between this Cl and Al, and between also this Cl and Al, there is a covalent bond. So the 2 electrons here and the 2 electrons here, it will be from Cl. Okay, 2 coordinate bond between Cl and Al. Okay, so here, if you look at this, this is wrong because there is bond between Al, and this is wrong. Al is not bonded. Here, this one is wrong because there is all of them are normal covalent bonds. Normal covalent bond. There is no coordinate bond. So this one is wrong. And this one is correct because these 2 bonds are coordinate covalent bonds. So D is correct. Question number 7. In this question, you should assume that methane behaves like an ideal gas. Like an ideal gas, so the gas laws can be summarized in the ideal gas equation. PV equals nRT, and the volume of a sample of methane is measured at temperature 60. On temperature 60, we have to convert it to Kelvin by adding 60 plus 273, and the pressure is 103. We have to convert it into Pascal because it's kilopascal, so 103 times 10 to the power of 3, and the volume is 5.37 times 10 to the power of -3. We have to keep it as It is. And of course, R is 8.31. Okay? Right. Find the mass of the sample of methane. We know that number of mole equal mass over molar mass. So we can rearrange this equation by assuming that PV equals nRT. So we can say that PV equals M over MR RT. So MR equals MR PV equals M, which is mass times R times T. So mass equal MR PV over RT. Just substitute. As you can see here, you can substitute to find the 16, which is the MR of methane. 16 times 103 times 10 to the power of 3 times the volume, which is 5.37 times 10 to the power of minus 3 over R, 8.31 times T in Kelvin, equal 3.198, which is equal 3.2 grams. So the answer is C. The equation for the formation of ammonia, which is Haber process of formation of ammonia, is this one. Okay. Some bond energy is given. The bond energy of H is 436, NH is 388, and the delta H is given negative 92.2. We know that delta H equal the sum of the bond energy of the reactant minus the sum of the bond energy of the product. In the reactant, we have 3H2, and we have N2 minus 6 NH. Why 6 NH? Because ammonia is NH3, as you can see here. Ammonia is NH3, 1, 2, 3 bonds. Okay? So these 3 bonds, 3 NH, we multiply it by 2 because we have 2 here. Multiply it by 2. So we have total 6 NH. So here we have 6 NH. Okay? So substitute minus 92.2 equal 3 times 436 plus X minus 6 times 388, which is the bond energy of the NH. So rearrange the equation, minus 92.2 equal X, which is NN, minus 1020, so X equal 927.8 kilojoule per mole, and the closest one is this one, which is 928. Question number 9. The diagram shows the energy cycle with a series of reactions. Okay? Which reaction have the enthalpy change? That is an enthalpy change of formation. The enthalpy change of formation is the formation of 1 mole of a compound from its element under standard state. So if you look at this, these are elements. Okay, these are elements together, they will form this compound, and the elements are in their standard state, and this compound is 1 mole. So we can consider one enthalpy change of formation. Here, if you look at this, we have here 1 mole of carbon monoxide. We have 1 mole of carbon monoxide, okay, from the elements under standard state. So we can consider this also an enthalpy change of formation. Okay, here formation of CO2 here is not from the original element. It's not from the elements in the standard state. It comes from the reaction between CO and O2. So we can consider this enthalpy change of formation. But in case of 5, if you look at 5, CO2 is the same as CO2. So it's not formed. But H2 and O2 in their standard state are combined together to form water. So we can consider 5 enthalpy change of formation. We can consider 1 enthalpy change of formation. We can consider 2 enthalpy change of formation. So the answer is A. Question number 10, the reaction is, which reaction is disproportionation? Disproportionation is when the element undergoes oxidation and reduction. If you look at this, here oxygen is -1, H2O2, the oxygen is -1, and here oxygen is -2, and here oxygen is 0. So here oxygen is reduced, and here oxygen is oxidized. So the answer is A. But if you look at the rest of the compounds, here nothing happened because everything is the same. Here potassium +1, hydrogen +1, carbon +4, and oxygen -2, and the same in the product. So nothing happened. Here, if you look at this, you will find that Mn here is +7. Here, Mn is +6 and +4. So Mn undergoes reduction. And here, oxygen, it was -2 and it becomes 0. So it undergoes oxidation. So it's not disproportionation. If you look at this, here nitrogen is +5, nitrogen become +3, so reduction. And oxygen, it was -2 and it becomes 0. So this is an oxidation. So this is not disproportionation. So the answer is A. A compound W contain chlorine with the oxidation state +7. This is easy. Just calculate the oxidation state in each one. Here, the oxidation state of chlorine is -3. Minus, if you want to calculate it, we can calculate it in this way. We can consider NH4 +1. So here, this one is -1. Okay, and here NH4ClO3. Here NH4 is +1 and O3 is -6. So Cl is +5, and here NH4 is +1. All NH4 is +1, and ClO4 is -2 times 4 equal -8. So Cl is +7. So the answer is C. Okay. In an industrial process, two gases X and Y react together to form a single gaseous product, Z. X and Y form Z. The equilibrium percentage of a product Z varies according to the pressure and the temperature as well. And this is a reversible reaction. Okay. But if you look at this reversible reaction, which statement of equilibrium is correct? If you look at this reversible reaction, you will find that the lowest temperature is this one. It gives the highest yield. Since the lowest temperature gives the highest yield, so the forward reaction is exothermic. So the forward reaction is exothermic. Since the forward reaction is exothermic, so as you decrease the temperature, the yield will increase. Okay. Right. So choice number 1, decreasing the temperature decreases the value of constant. Of course not. Why? Because since the reaction is exothermic, if you decrease the temperature, the reaction shifts to the forward. So the product will increase. You know that Kc, the equilibrium constant, equal the product over reactant. So if you decrease the temperature, the product will increase. And the reactant will decrease. So the value of the equilibrium constant will increase, not decrease. The value of the equilibrium constant will increase, not decrease. Decreasing the temperature increases the rate of the reaction. Of course, not. Decreasing the temperature decreases the frequency of collision, so it will decrease the rate of collision. Increasing the pressure has no effect on the value of the equilibrium constant because only temperature changes the equilibrium constant. The last one, the reaction is exothermic in the forward direction. Of course, this is correct because as the temperature decreases, the equilibrium yield increase. So the forward reaction is exothermic. 13, the contact process involves the equilibrium reaction. This is the contact process. Which row gives the Kp expression for the and the pressure the Kp expression and the pressure conditions used for this reaction? You know that here, if you want to calculate Kp equals the concentration of the product, which is SO3. Sorry, the pressure of the product, it's written here. The pressure of the product to the power, the pressure of the SO3 to the power of 2, okay, over the pressure of SO2 to the power of 2, because we have 2 here, times the pressure of oxygen to the power of 1, because there is no coefficient here. So this is the expression. This is the expression which matches A and C, but the pressure for the contact process is only 2 atm, so the answer is A. When nitrogen monoxide gas is mixed with oxygen gas, nitrogen monoxide, NO, with half O2 gives NO2. All of them are gases. Okay. The molecule collide with each other. Some of these collisions are effective, lead to a reaction, and the pressure of the mixture was increased at constant temperature, which Rho correctly described how the frequency of the effective and non-effective collision increase. You know, if this is a container, and in this container, for example, if some of these, for example, these particles will collide effectively, and these particles will collide less effectively, for example. Yeah. Okay. So when you increase the pressure, on the container, so all the collision will increase, the effective and non-effective collision, all of them will increase, but the reaction will happen faster. And since the frequency of the effective collision happen faster, so the reaction will be faster. So both the frequency of the effective collision and the frequency of the non-effective collision will increase. A reversible reaction is studied, question 15. The forward reaction is the activation energy is 50. The activation energy is always positive. And the enthalpy change of the reaction is plus 20. So the reaction is endothermic. When a catalyst is added, the activation energy of the forward reaction decreases by 50%. So instead of 50, it becomes 25. What is the activation energy for the backward reaction when catalyst is added? Right. Let's see كده. This is the endothermic reaction. Okay? Before catalyst, without catalyst. Okay? But the total EA, it was 50. And the delta H, it was 20. So the activation energy of the backward reaction is only 30. So this is the activation energy of the backward reaction. Okay? But when you add catalyst, delta H will not change. Okay? But so delta H will stay 20. So when you when you add catalyst, the new delta H, the new activation energy will be 25. Okay? But so this from here to here, it will be 25. If you subtract 20 from 25, so the new activation energy for the backward reaction will be only 5. Also, you can find it from here. E from the backward reaction equal the activation energy minus delta H. So for the reaction without catalyst, for the first one, you can find the E of the backward reaction, 50 minus 20 equal plus 30. Okay, this is without catalyst. But in the presence of catalyst, the new E will be 25, but delta H doesn't change. So you can find E, the activation energy for the backward reaction by subtracting the new activation energy, which is 25 minus 20, which is delta H equal 5 kilojoule per mole. Okay. Question 16. Which substance doesn't give HCl when water is added to it? Which substance doesn't give HCl when water is added to it? طبعا MgCl2 and the NaCl, both when you add water to them, they just dissolve in water. Gives pH 6, gives pH 7 here in case of NaCl, and pH 6.5 in case of MgCl2. But Al2Cl6, SiCl4, PCl5, all of them, they react with water to produce acidic solution. Here the pH is 3, and here the pH is 1 or 2, as if you remember. So if you want to remember the equations, here the equation is SiCl4 plus H2O gives SiO2 plus 4HCl. And here PCl5 plus 4H2O gives H3PO4 plus 5HCl. And Al2Cl6 plus H2O gives AlOH by 3 plus 6 HCl. These are the equations if you want to remember them. So the answer is A. Question 17 for group 1 and 2. Metallic bonding is stronger in metals that have a smaller atomic radius. Smaller atomic radius. X and Y are both metals. Delta H of atomization is the energy required to produce 1 mole of gaseous atom from a solid. يعني for metal, imagine that we will break the metallic bond. Imagine that we will break the metallic bond between to change the solid metal into atoms. Okay? Right? So delta H of atomization of X equal plus 107. And delta H of atomization of Y equal plus 148. So this is delta H of atomization of Y greater than the delta H of atomization of X. And since delta H of Y has greater, delta H of atomization of Y is greater than X, so Y has a stronger metallic bond, and this means that according to what he said here, it has a smaller radius. Okay, if you compare it here, you will find that Na and Mg, طبعا Na it has يعني Na ion and Mg ion. If you compare them, you will find that Mg ion is smaller than Na ion. So, and also even the atom of Mg, because the atomic radius, as you go from left to right, the atomic radius decreases, because here he said the atomic radius. So since the atomic radius of Mg is smaller than the atomic radius of sodium, okay, so Y is magnesium and Na is sodium. Okay, so the answer is B. The elements in period 3 and their compound show trend across the period from sodium to sulfur. The elements in period 3 shows a trend in across the period from sodium to sulfur. Which row is correct? طبعا you know that as we go from left to right in the period, the electron negativity increases, and also the ionization energy increases because of decreasing the radius and more attraction force. So the ionization energy and the electronegativity as well here, it will increase. So the answer is C or D. And acid-base behavior of the oxides of the elements. طبعا you know that sodium oxide is basic, magnesium oxide basic, aluminum oxide amphoteric, and the rest are acidic. So as we go from left to right, it changes from basic to amphoteric to acidic. So the answer is C. 19. The question about hydroxides, carbonates, and magnesium and barium. Okay, magnesium up and barium down, right? But which row is correct? طبعا, as you know, the solubility of group 2 hydroxide increases down the group. So barium hydroxide is more soluble than magnesium hydroxide, which is very soluble in water. And also the thermal stability increase down the group. Thermal stability increase. So BaCO3 is more stable than MgCO3. So the answer is A. The answer is A. Okay. طيب. Here, when when 3 grams of anhydrous nitrate of group 2 metal is decomposed, 1.53 grams of a gas is produced. What is the nitrate of the compound? Or what is the nitrate compound? This question is depends on trial and error. Yani we have to find based on to find the compound based on the calculations. So number one, we have to write the thermal decomposition of nitrate of each one. So all of them are the same. 2 metal nitrate gives 2 metal oxide plus NO2 plus O2. And NO2 and O2 are the gases which are formed. Okay? So we need to find the relation that produce 1.53 gram from 3 grams of the compound. So here for the first one, find the MOR of each compound. These are the MOR of each compound: beryllium nitrate 133, calcium nitrate 164, magnesium nitrate 148, and 212 for strontium nitrate. So when we write this equation, don't forget that the total mass of the gas produced based on the number of mole. For NO2, the total mass is 184. O2, the total mass is 32. So the total mass of the whole gases produced is 216. 216. So if we put beryllium nitrate, 2 moles, so 2 times 133 produce 216 of the gases. So 3 grams produced. If you calculate it, you will find that the mass is 2.43 grams. So this is not the correct answer. This is not the correct answer because the relation is wrong. Okay. But the second one also, if you put calcium nitrate, the same equation, exactly the same equation, but for calcium nitrate, 2 times 164 produce 216. So 3 grams produce, make cross multiplication. So the volume or the mass of the gases produced is 1.979, which is wrong. For magnesium nitrate, if you calculated 2 times 148, the MOR of magnesium, produce 216 of gases. So 3 grams produced, question mark, you will find it 2.18. So C is wrong. So B wrong, C wrong. So automatic the answer is D. Let's make sure for D strontium nitrate. So the MOR of strontium nitrate is 212. So 2 times 212 because it's the same equation. And instead, but you will change the method. So 2 times 212 produce 216. So 3 grams produce, make cross multiplication. 3 times 216 over 2 times 212 equal 1.528 gram, which is 1.53. So the answer is 20. Okay. That's it for the first part of the exam. Thank you.